water is the liquid required for life. Its unique properties, from polarity and hydrogen bonding to high specific heat and cohesion, are derived from its unique chemical structure. Water's strong covalent bond forms through a subatomic tug-of-war. Oxygen is significantly stronger and pulls the shared electron closer, leaving the smaller hydrogen exposed. This electron shift creates polarity, a magnetic engine for biology. The molecule develops partial charges, with one side slightly negative and the other slightly positive, forming the source of its life-sustaining power. Water's polarity makes it the ultimate solvent. It easily breaks apart charged ionic salts, aiding in metabolism. Conversely, it repels nonpolar lipids, helping biological cells maintain their shape. This property is what allows the blood, which is mostly water, carry nutrients and ions, electrolytes and buffers. Water exhibits a density anomaly. When it freezes, maximum hydrogen bonds form a spaced-out lattice. This makes solid ice less dense than liquid water, allowing it to float and insulate aquatic life. Water can defy gravity through stickiness. Cohesion, a self-sticking effect, creates surface tension that allows insects to walk on water. And 4 is how our blood flows. Adhesion, where water sticks to other polar molecules, helps it move up blood vessels. Thermoregulation is the body's fluid cooling system. Water has a high heat capacity, which means the molecules can absorb a lot of heat before boil. In animals, the water in the blood absorbs heat made from our metabolic reactions and transfers it to the skin's surface through our blood vessels. This is why you get red when you are hot. The blood capillaries have moved closer to the surface to release heat. Evaporative cooling occurs as the water in sweat transitions from liquid to gas, removing thermal energy from the skin. This creates a cooling effect. Therefore, water acts as a global thermostat. Internally, blood water regulates body temperature. On a macro level, water vapor in the atmosphere absorbs the sun's energy and traps warmth, preventing extreme temperature swings. The pH spectrum is determined by the ratio of broken water molecules, hydrogen ions, H+, or hydroxide ions, OH-. Acids flood the solution with H+ ions, while bases flood it with OH- ions. Homeostasis involves a pH balancing act, primarily regulated by the respiratory system. Carbon dioxide combines with water to form carbonic acid, influencing blood pH. If blood becomes too acidic, we breathe faster to excrete CO2 and restore balance. pH balance is just one example of homeostasis. All homeostatic mechanisms follow basic steps: stimulus and detection, integration, output and response, and effect and balance, using a negative feedback loop. The architecture of a water drop reveals that all of water's life-sustaining properties are a cascading result of a single unequal subatomic bond, leading to polarity, hydrogen bonding, and all its unique traits. Water is the universal signature of life. Its physical and chemical mechanics perfectly align with the requirements of biological life, making it the single most important indicator for scientists searching for life on other planets.